All right, welcome back. Welcome back. We've got a bunch of stuff to cover in today's kidney session, and I see most everybody stayed. So hopefully I did a good job in the first session to convince you. But as far as our session right now, it is not going to be brain memorization stuff. It is actually going to be, for the vast majority of it, application stuff. Dealing with how to apply the way the kidney gets tested on the MCAT to actually make sure you garner the points you deserve on test day. And like I promised in the kind of intro from the last video, we are going to be focusing mostly in kidney 2 on a lot of the hormones, a lot of the endocrine functionality, and really on system-wide application. So even if you didn't come to kidney 1, today's session is a great session for you to attend sort of separate from that one, actually, since that one talks almost exclusively about the functionality of the nephron and the overall structure. So we're going to jump in, of course, with kidney control, hormone control, and then do a lot of practice problems. This is really a great session for putting into play what you have been studying. And just to make sure we have enough chance to play with a lot of those problems, I'm going to let our phenomenal teacher Chuck toss that answer poll down there in the bottom right, and we'll just keep it there for the whole session, because we're going to do a lot of problems back to back, and I want to make sure you have plenty of room there for voting. First of all, as far as kidney functionality goes, there are basically two main players. These should not be unfamiliar to you, but let's run through them piece by piece to make sure we're all on the same page. First of all, if we're talking about some sort of ADH, we mentioned this a second ago, ADH is antidiuretic hormone. That, compared to aldosterone, though, is a particular type of hormone class. What is the class of hormone that ADH falls into? By class of hormone, I mean exactly? I don't have to elaborate anymore. Good, Dorothy. Awesome, George. So it's a peptide hormone versus aldosterone, which is a steroid hormone. And again, ADH, antidiuretic hormone, aka vasopressin, being a peptide hormone, means what about its functionality? What about the speed? What about the effect? It's fast acting, exactly right, Marissa, which is important for us. Quick acting, and nice, Esther, absolutely. Good, Alejandro. So fast acting, quick response mechanism. Now, aldosterone, on the other hand, is steroid hormone. Be a slower onset, longer duration, could be a duration for the vast majority of someone's life, depending on what the triggers are that are actually creating aldosterone release. As far as triggers, ADH is triggered by a high plasma osmolarity, but aldosterone is triggered by a low blood volume. Remember, these two do the same sort of net action on the body, but they are absolutely different, and the MCAT loves to try and trip you up by confusing one for the other. So high plasma osmolarity versus low blood volume. Okay, let me test you on this. Suppose after my race was over, I hadn't had any water during the race because I didn't want to stop, and I also didn't drink any water right after the race. So I ran about 6.5 miles or so with no water. What do you think should be functioning? ADH, right? High plasma osmolarity. I do not have a lot of water in my system. I have a lot of excess salts. Okay, well, I've got a high plasma osmolarity. And on the MCAT, they might ask you something like that. They might say a person has not had any water for 3 days. Okay, no water for 3 days. Sounds like dehydrated. Dehydrated sounds like high plasma osmolarity. Cool. I might ask you the second question. It might be the same one, or it might be different. What do you think would be the response if I all of a sudden right now chugged 3 liters of water? What should be the body response? I said it might be a trick question, just FYI. Ooh, negative feedback. Well, decreased ADH at least, definitely. Definitely, Dorothy, right, Sarah? Inhibition of ADH as low as possible, right? If I chug 3 liters of water, I am not lowering blood volume. I should be increasing it. And I do not have high plasma osmolarity. I have really low plasma osmolarity. I wanted to ask that as a trick question because the MCAT sometimes, even on a passage all about ADH and aldosterone and caffeine and all sorts of stuff, they might throw something at you like that, which actually is the exact opposite of a salt intake or a low blood volume question. Cool, cool. Okay, now, as far as that's our trigger. Our trigger is either high plasma osmolarity, tons of excess salts, or low blood volume. We just don't have enough water in the entire system, or we have a longer low blood volume in the afferent arterioles, triggering renal, blah, 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 adrenaline response. So how about effect? What is the effect when ADH is acting on the body? Specifically, what has to get opened or what has to get closed? We have to pick up water. You got it, Navina. So if we're picking up more water, I want to be clear here. We're picking up more water into where? When we're absorbing more water, into where? It opens the aquaporins in the distal convoluted tubule, which is right near the collecting duct. Exactly, Lydia, right, Matthew? And when we say we're absorbing more water, we mean absorbing more water into where? Into urine? Oh, good, back into the bloodstream. It had better be, Sarah, because if we've got high plasma osmolarity, I want to make sure I absorb that water back into blood so my blood doesn't have such high osmolarity. Cool. Excellent, Matthew, right, Esther? So, okay, bonus question here. Before we get there, we should probably talk about aldosterone. What is aldosterone specifically acting on? What is its effect? And the aquaporins, to Elizabeth's question, the ones that would be affected by ADH are primarily on the distal convoluted tubule. They're actually not primarily on the collecting duct. ADH are primarily on the distal convoluted tubule. Good question. Good question. I should have been more specific. It is increasing sodium-potassium pump. You got it. Sarah, yes. Navina, Kelsey, absolutely. Now, bonus question to add on to what Elizabeth said a second ago. ADH is acting to increase water outflow at the distal convoluted tubule. Where is aldosterone acting? It's not the same place. Where is aldosterone acting? Mostly on the collecting duct. Exactly right, Sarah. Exactly, Esther. So again, primarily on the collecting duct. Now, I did have a bonus question in mind. Oh, I remembered it. Good thing. I almost got distracted. Before class today, I didn't eat anything, but I know that Chuck did. Chuck, of course, is answering tons of questions in the Q&A. If you haven't seen him a little bit in chat, that's where he is. But Chuck, right before class, ate a 1-pound bag of salty potato chips. Now, what do you think is responding when Chuck ate that 1-pound bag of salty, extra salt, like sea salt crusted potato chips? What do you think is responding? Salt is in, water follows salt. You're right, absolutely, Lydia. But this would be ADH. We need a fast, instant response. We need to make sure that that salt does not increase the osmolarity of plasma. So immediate ADH response, as Elizabeth pointed out. Philip, yes, absolutely, Jennifer. Now, bonus question. Suppose I tell you that Chuck does love salted potato chips. In fact, for every meal, whether it's before as an appetizer or after as dinner, Chuck tends to eat a bag of salted potato chips. Now, what do you think is responding? It's a little bit of a trick question. You're right in saying aldosterone, Matthew and Jennifer, but both, right? Aldosterone should be a steroid, long onset, long duration response system. Absolutely it's acting at this point, but your body doesn't know that aldosterone is acting because they're not talking to each other. Peptide hormone is still going to come in here and bump that thing up. Wait a sec. Now we're getting exciting. What do you think is going to happen if Chuck has his high salt diet for a long time and aldosterone is acting overall, but the peptide hormone is acting instantaneously each time anyway? Yeah, exactly, Esther. Yeah, for sure, Sarah, right? Because one is lowering the blood osmolarity by making sure we have more water reabsorbed, and the other is making sure we increase the sodium-potassium pump to get more water to flow in that direction. Oh, goodness. So we're increasing way more water into our bloodstream. That sounds like high blood pressure. That sounds like hypertension. Hence the United States' war on salt. Oh, suddenly it makes a lot more sense, right? Because our body isn't talking one of these to the other thing, so they're both overacting. Bummer times. We don't want that. Now, certainly, Esther, we should be drinking a lot more salt, a lot more water, excuse me, salt, a lot more water as a country in general, especially considering the salt intake. Now, okay, last up about ADH. There could be some questions, like I mentioned, on test day about the overall effect, besides what the actual effect is of that particular hormone, what the overall effect is on the body. We talked about this briefly, but just to be clear, ADH reduces plasma osmolarity by allowing more water to move back in. Aldosterone increases blood volume because water follows salt. So if they're pumping salt back into plasma, water will follow that salt back into plasma. So both of these are moving water into plasma. Both of these are trying to maintain homeostasis, the same osmolarity, but they're doing it in definitely different ways. And this is, again, classic MCAT, trying to confuse you on which one is which. So let's take a look at a little bit more details before we do a problem, just to make sure we're all 100% clear. Up there at the top, it looks like we have a couple receptors. Those little receptors there at the top had better be receiving which of those hormones if that's on the distal convoluted tubule region. It better be our aldosterone mostly. ADH mostly. Again, this is labeled wrong. ADH should be on top. ADH is mostly acting for water uptake here, and aldosterone is acting mostly for salt movement here. ADH is distal tubule. So we were right. We were right. No worries. I don't know why it says mostly on there, but ADH should be on the top because that's where we're reabsorbing more water, right? We can think about this in general. Maybe those arrows got shifted for some reason. I don't know what's up, but it should be ADH mostly because here's where we've got tons and tons of surface area. If we're trying to remove back out all of those delicious solutes that we didn't get out earlier, like some extra glucose or some extra amino acids, that's where water is already flowing out easily, so we're increasing more. As far as aldosterone mostly, aldosterone would be acting more, again, on some salt movement. So we could have a lot more salt movement that then pulls more water out as well in the collecting duct. No worries, we got it from a second ago. Now again, both, just to be clear, are increasing water reabsorption, so both are effectively giving us more concentrated urine. No worries. So let's suppose we had a question like this. I promised we would see an MCAT style question. No, in the MCAT, again, this would be a discrete question they might give you. In this case, they're talking about a hiker, but they could talk as easily about a lab experiment or about some sort of a mouse. Any other system should still have the same sort of functionality. So let's take a look, and of course, Chuck is going to toss down the bottom right that answer poll again, so you can poll in as soon as you've got it. But let's look for a couple key pieces. What do you notice right off the bat that's going to be a key piece for us to figure out which of these is acting? That's a key hint. No water intake, exactly, for 2 days. Interesting. No water for 2 days means definitely dehydrated. Okay. Now, definitely dehydrated implies what? Dehydrated implies what about our body systemically? I don't want to give you too many hints. High plasma osmolarity. Ding, 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 ding. Sarah, Jennifer, Tristan. Okay. High plasma osmolarity means who has to respond? Even though it's been 2 days, even though they should have responded earlier already. Thank you very much. Better be ADH. Nicely done. Answer choice D. And if you have not had my class before, we didn't have very many questions in the past one, but yes, over 90% for the right answer is B as D, Navina. You've been in plenty of my classes. That is what the MCAT will look like when we crush questions like this. Because I guarantee you, a lot of the students sitting around you are not going to have remembered the difference between ADH and aldosterone, and they're going to be accidentally choosing answer choice B. No way. Absolutely ADH for high plasma osmolarity. Done. Crushed it. Now, the follow-up is a lot of MCAT questions, if it's something relatively basic, like the difference between meiosis and mitosis, or the difference between ADH and aldosterone, as far as AAMC is considered, those are considered basic. They might give you advanced questions that test you on things going wrong, or new experiments about some stuff that we might expect to know a lot about already. So for this one, we've got two answer choices, either A or B. And they have an experiment, apparently. So the experiment is about what is caffeine actually doing. We know it's a diuretic. We've been told it's a diuretic. But what is actually happening? Is it blocking ADH receptors, or is it blocking ADH release? Now, I've got a bonus question here before you answer in. If you know this, if you've already done these studies, or if you memorized it in undergrad for some reason, do you have to read the table? If If you already know for sure what it does. Now, unfortunately, the answer, Molly, is yes. Tristan is yes. Unfortunately, there's one key word in the question that tells us we have to read it. Yep, you got it. Based on the results below. Yep, exactly, Sarah. Now, if that hadn't been in there, now answer. If it hadn't been based on the results below, could we have done this without reading the table? Yes. Always, actually. Unless you have an experiment, unless you're interpreting data, if you know something from outside science, they cannot give you bad science. Unlike the cars section, where they could give you a passage about ponies and rainbows and about how that equals depression. I don't know. They could give you something wild. But as far as science goes, they have to give you real science. So if you know the right answer because you've already studied this, then that will be the right answer. Now, in this case, because they tell us we're basing it on these results, we should check out the results. So let's run through each of these groups very briefly. Categorize for me, what might you call group 1 in an experiment? What might you call it? It's a control group, right? No caffeine, no injection, normal urine. Sounds like our control group. Great. Now, again, as far as a control group is concerned, we might see it as the none, like we see here. We might see normal, but we might also see some other reference shorthand. So, for example, for caffeine, yes, we might see like a plus here to represent we added this, and then none for ADH, and then a plus for high, or an affect, right? Positive effect versus negative effect, you might see as pluses versus minuses. Just to be clear, I want to make sure you're absolutely ready to read any chart they give you. Now, hold on. Added caffeine, okay, higher urine output. Well, that was expected. Now, let's check out the real experiment, which is what they were asking about, which is what happens when there's caffeine and injection. Normal. Okay, so group 1 is the original control. Group 2 is sort of the caffeine control, if you want to think of it that way. And then group 3 is our actual experiment group. And it looks like, well, help me out. Did the ADH injection work or not work? Just to be clear. Worked. Yeah, absolutely, Esther. Right, Philip? Right, Kelsey. So I see a huge number of people answering this one right, which means you do get a star. But we're at 85%. We're right there on that cusp. So if it worked, when we added ADH, that must mean that there was a problem with the release. Yep, receptors must have been there. Exactly, Jennifer. Because if we added it and it was uptaken, there must have been receptors. So, well then B makes the most sense. Caffeine must have been preventing ADH from getting out in the first place. And that is, like I promised, we do get a gold star because that was over 80% for the right answer, which is phenomenal. Nicely done. Now, again, this is, yeah, in this case, Esther, in this experiment, it was a problem with the release. So caffeine blocks ADH release, so ADH never got out there in the first place. Now, we don't necessarily have to know what mechanism it used to block, what else was a cofactor for the blocking. None of that stuff is related at all to this particular answer. It's really just, apparently, caffeine blocks ADH release due to this experiment. And the reason it's due to this experiment result is because when we added ADH, that did have an effect. And if it had an effect, then the receptors must have been fine, because we had a positive, well, in this case, we had a negative effect due to it, but we had an effect. So it must be the case that whatever the other answer is, ADH release apparently was the problem in the first place. Good question, though, because this is the sort of thing that the MCAT likes to ask about. Things may be going wrong, or experimental groups where we have to really pinpoint what's going on at the foundation level, basic structure. Now, let's do a bunch more of these questions because we've got a ton more to really test out kidney functionality in general. First up, I want to toss this one up on screen, and I want to give you about 2 minutes to read through this passage. I'll add, just for fun, Then a passage like this is a little short for MCAT standards, but they might have this passage and then a couple diagrams, or this passage and then like a flow chart of something. So reading this passage, assume that you would have gotten also like a flow chart or a diagram or something. 2 minutes on the clock, though, to scan through. And then down here in chat, I want to know, what would you have outlined? Go for it. All right, let's jump in. So to Elizabeth's question, yeah, let's do a little bit of outlining down here in chat. But actually, I've got sort of already a bias about this passage, because this is the sort of thing that the MCAT loves to throw at you. A passage about stuff that maybe we already know. Did anybody find while they were reading down through, it was like fluff, 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 already know this information? I'll go ahead and raise my hand. Absolutely. When this happens to you on test day, do not hesitate to scan ahead. As soon as I started reading vasopressin is also called ADH, yeah, okay, got this. Scan, scan, scan. Now, when I'm scanning, there are a couple of things I always look out for. And I'm going to stop here and kind of talk about this with you, because if your teacher hasn't mentioned this before, I want to be very clear about it. Where might I pay a little bit more attention? Even in just the first paragraph. Yeah, parentheses. If your teacher hasn't mentioned this to you before, I want to mention it now. Parenthetical statements on the MCAT often tend to be information that they're going to bring back up later, because when you're reading, a lot of people skip over parentheses by accident. So in parentheses, osmotic pressure is specifically plasma osmolarity in osmoles per liter. Okay, now it didn't end up being anything super amazing. It's stuff we probably already know also, but it's important for us to notice, exactly as Philip points out, they're dealing with this in osmoles. Often for the human regulatory system, we use milliosmoles. So if they're going to be giving it to us in osmoles and we're used to milliosmoles, we're going to watch out for some answer choices that are off by a factor of 1,000. Yeah, exactly, Navina. But that's the sort of thing. Notice it was in parentheses. We might have missed it if we hadn't been noticing that briefly. Now, I scanned through. They've got a reaction about how vasopressin works, blah, 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 fluffy. Conversely, we might have decreased if there's too much. Yeah, okay, so negative feedback mechanisms. Got it. That's what we're talking about overall. And as you're reading down through, hopefully, you would be thinking about what else is related to this. What else should come up in the question set? So help me out down here. What else might come up in the questions before we even look ahead? What else are we likely to see? Aldosterone, for sure. Absolutely right. What else? A couple more things. Just spitball off the top of your head. What else could be related to any questions about ADH or vasopressin? Relationships between them, urine volume levels, absolutely, Jennifer. Urine volume makes us think kidneys, ding, 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 exactly, Molly. So nephron functionality, nephron structure, good. Relationship back to blood pressure, love it. But you see what you're doing? The best test takers take the fluff passage and then predict what are we going to see referenced later on. Nice. Plasma osmolarity, even aquaporins, sure, Kayla. Now we jump in and do some questions. But again, now we're pre-gamed for it, right? Let's take a look. A couple hints. Large quantity of water. And we're being asked about what will occur to the plasma osmolarity. Okay, so first of all, this is sort of a freebie. So plasma osmolarity had better go down since we've got a ton of water. But then what's going to happen to vasopressin secretion? Well, vasopressin gets secreted when we've got not enough water. So I guess there's less need for vasopressin, so it better be decreasing. Exactly. Dory, Valerie, Alejandra. ADH is proportional to plasma osmolarity. So if our plasma osmolarity dropped, then our ADH level necessary had better drop. Well, that's answer choice B. And we did see right about 80% right there for that. So that is absolutely our second gold star of the day. Nicely done. I'll pause a little bit later next time because I think maybe this could have been a black star of doom. So I'll give you more time on the next couple problems. Let's jump in. For this next question, it's dealing with some reference to vasopressin excretion and some amount of milliliter blood. There's a lot of text here. And I've put here on screen, just as a bonus, the chart that we brought up in Kidney 1. Just a general breakdown overview, a quick simplified version, just so you could use that maybe to work from. Let me give you about 30 seconds to try this one out. And if you spot the sort of trap to this one, let us know down here in chat. Don't give the actual answer, but what's the trap? Go for it. All right, let's take a look. The reason I wanted to give you a chance to try this out is twofold. One of which, of course, is that there are units here, right? Milliosmoles versus what it mentioned in the passage was about regular osmoles. So maybe we'd scan here for some problem with that. Now, fortunately for us, there's no mismatch. All of the answers are in milliosmoles, so all right, we're set. And the other thing is, I think what Elizabeth is getting at, I think you've got it. But a lot of people miss this question because they give us too much information. They're trying to flood us with extra fluff we really don't need. What's the question actually asking about? Exactly, Elizabeth, that's the whole point. What do we actually want to know? Yeah, at the end, what would be urine osmolarity? Okay, well, gosh, at the end, well, the end is right here, and we're urine now, right? This is the collecting duct. So at the beginning of the collecting duct, it's about 300, then it goes up to like 400, 500, 600 maybe. It probably is not going to go anywhere near 1,000 milliosmoles because that's like camel urine or horse urine. But yeah, we could have 3, 4, 500. So I'd scan through my answer choices, I mean, at least for 300. Because that's when we hit the collecting duct, we're at about 300. Well, yeah, that's D. 300 is the closest. Now, again, it's D because we're right here where I circled. We're right at the input, at the end of the renal distal convoluted tubule, right before we hit the actual collecting duct. So sure, we might be up there around 300. But yeah, exactly, Elizabeth. Normal urine is around 400, 500 is pretty normal. Anything over about 700 is very concentrated urine. and humans usually don't get concentrated urine over 1,000 milliosmoles. That range is usually for certain rats, horses, camels. They're the ones that concentrate urine up over 1,000 usually. And again, that's just a good reference point to think this is the range of values I'm looking for. So to a couple people who asked about the 1200 value, that would not necessarily be human nephron. That would be something that is massively over-concentrating like a camel usually. And no, Esther. You mean the most concentrated within the entire nephron? Great question. I love it. Let's pose it to class. Where would it be most concentrated? This is actually going to come up in a later question. Where would it be most concentrated? In the nephron. Because you're right, Elizabeth, at the collecting duct. Yes, that's true. But within the nephron. Yeah, Philip, which is called? Yeah, Alyssa, nicely done, loop of Henle. Loop of Henle would be the most concentrated it should ever be. And actually, loop of Henle is the way we determine generally the strength of the gradient in order to concentrate urine. So collecting duct is all the stuff over here on the right-hand side, right? Sort of like the drain. It goes down and out. But then the loop of Henle is the highest concentration we would ever get within the nephron. And the further down the loop of Henle is, actually, the stronger and stronger that gradient is that we can use to concentrate urine. So that's actually a good, right. The collecting duct is not technically part of one nephron. It is where all of the nephrons feed into. Good question. Good question. And that will go, of course, to the ureters, to the bladder, and then excreted via the urethra eventually. But yeah, it will all go into that one place. Good question. Nice follow-up question. As a bonus question I didn't even have to ask. I like it. Maybe a bonus star. All right, next up. All right, changing plasma osmolarity on vasopressin. Gosh, okay. This looks like it could be pretty complicated. Let's just double check the answers. Do the answers show a pretty complicated relationship? Right, because we could see a lot of relationships. No, the answer choices are all basic systematic mechanisms. Oh, awesome. Because I was about to get worried we were going to have to track which one goes up, which one goes down. But okay, vasopressin versus water. Well, let's think. When we have a low one of these, well, then we have to, if we have a high one of these and the other one drops off, if we have a high one, the other one turns on, which mechanism matches up with if we have too much of one thing, another thing turns on to kill it? Yeah, good. And to Elizabeth's point, absolutely. It looks like your other classmates, I didn't even confuse anybody by trying to pretend to confuse you a second ago. It does absolutely sound like a negative feedback loop. That is our thermostat mechanism, where if we have one thing that is too much, the other thing turns on. Boom. BSD. Absolutely. Again, this is one that we didn't even need the passage, right? This was a pseudo-discrete question thrown in here to try and trip us up, but crushed it. Absolutely negative. Look at how upset that star looks. That is a black star of doom for the MCAT. MCAT is like lopsided even. That's how upset. Let's do it again. For this next question, we've got a reference to maybe something that I didn't quite do today. 10K is not really a marathon. But we've got running marathon, we've got salty meals, we've talked about these before. All of these are possible matches to whatever is happening here for question 6. Go for it. Try it out. Now, while you're doing it, there are like 2 hints they give you in this question. 2 hints. What were they? No vasopressin is one clue, right, Marissa? And Elizabeth's got the other one, impermeable to water. Okay. So it's definitely not dehydration. That's a good way to think of this, Valerie. We're definitely not dehydrated. And A and B, exactly right. A and B sound like running a marathon, eating a salty meal, sound like those would be conditions that would be dehydration that would cause us to be permeable. So it can't be A or B. They're both, wait, even if we weren't sure, they're both the same condition. If they're both the same, could they both be right? No. So they both must be wrong. Cool, get rid of A and B. And we do have, like I said, crushing this one, over 90% for answer choice C. Man, oh man, absolutely. And if we have a lot of fluid, we talked about this earlier, if I chug 3 liters of water right now, I should have almost no vasopressin because I've got so much excess of water, I'm going to have to send that straight through to the collecting duct as urine. Done. So again, first two are opposite. They are exactly the thing that would cause vasopressin. And then D doesn't even necessarily, spending hours in a cold environment would be vasoconstriction. Absolutely, Marissa. So we might be maybe tempted by it, but again, we could eliminate it because it should not be dealing with any sort of relationship directly to water. Cool. Now, next passage. We can crush this one too. Let's take a look. I want to do the same thing we did a second ago, but I want to give you time to actually do an outline. And then what I'm going to do is I'm going to call on certain groups of you, like first name A through E, for example. I'm going to ask for your outline for a particular paragraph. So I really want you to do it. And just to prove that I really want you to do it, I'm going to give you 3 minutes to make sure you actually do a full outline. I'll be quiet. Go for it. 3 minutes, passage 2. All right, let's jump right in. Now, I've got a couple things that have come up in these paragraphs. And again, I want to see how you're outlining these. I will take the first paragraph. How about that? It's only fair. I'll take the first paragraph. It is the shortest one, and I'm the teacher, so I get to choose it. So I've got a hot, dry environment. That makes me think hot, dry environment sounds like dehydration. Sounds like maybe I'll get some questions about vasopressin. And since it's a hot, dry temperature, I might have something about thermoregulation. Now, scanning through the rest of the paragraph, I see body temperature by circulation. I predicted that. Vasodilation, that was a parenthetical statement. I wanted to read it very carefully. Check. I already noted it. Evaporative cooling, parentheses, sweat glands. Check. Absolutely. I would expect that because, again, that's thermoregulation mechanism that's normal, but I wanted to read the parentheses. And severe heat, dehydration, regulatory, okay, yes. All makes good sense. So on my outline, I would probably only write down homeostasis, thermoregulation, because there's nothing crazy going on here in the first paragraph that wouldn't be something I would already associate with thermoregulation. Again, the outlines should be detailed if we need them, but otherwise they can be very brief if we don't. Okay, so now, if your first name begins A through I, give me your outline for paragraph 2. First name A through I. Okay, excessive sweating and homeostasis, good. Alyssa, Esther, both great. Dory, cool, fast. And again, this clearly seems to be what it's talking about. They've got all these numbers in here. Nobody put numbers in their outlines. How come they didn't put those in? It's good. We don't want them in there. It's not where they belong. Why not put down 1 to 1.5 and then 0.5 as the low value and then near 0 as, because we can go back to them exactly right there. We know exactly where they're going to be. Excessive sweating, disrupting homeostasis, and where were the numbers? Paragraph 2. Exactly, Connie. I might even recommend, to Marissa and Esther's point, I might even recommend highlighting the extreme one, but I probably wouldn't recommend highlighting all of them. Normal value is 1 to 1.5. Maybe highlight the renal salt near 0 number, because near 0 sounds like it's the extreme one. But highlighting all of them means we have to go back and reread all of them anyway. Remember, highlighting should always be helpful to avoid you rereading multiple points. So if we highlight, in a Carr's passage, for example, if we highlight every time that they mention some scientist, or we highlight every time they mention the author of the passage, then we're going to have to go back to every single one. But the first time they mention it, or the most important one, that's the sort of stuff that we usually highlight. Good point, though. Highlighting, we definitely could do a little bit here as well. Now, I like this. We've got a good reference to excessive sweating, something about, Elizabeth goes into a lot more detail, and I like that. Increased sweating means decreased urine, means we've got some sort of nasal excretion, so kidneys fail to maintain normal urine output. If you're going to jot down a couple notes like that that are related to each other, I highly recommend forward arrow for your shorthand. Increased sweat, forward arrow. Decreased urine, forward arrow. Maybe you already did this in your scratch sheet, but highly recommend quick shorthand. NaCl, good. Now, paragraph 3, first name J through V. First name J through V. What is your outline, paragraph 3? Sure, I like that. I like that, Molly. Urine concentration with the brackets, that's a sweet shorthand. Perfect. Other concentrations, other animals, homeostasis, right, Tristan, right, Morineke, and better adapted than humans, I like that. And what Jordan put in here, what Navina put in here, the 4 times concentration, the super high concentration, I like that because this is one number, right? So since it's only one number, we could either highlight that or we could even jot it down if it's the one number we have to remember. Notice how this differs from paragraph 2. I wouldn't jot down those numbers or even necessarily highlight those numbers, but in paragraph 3 I would. That's that sort of difference we want to be doing for just good note taking. So up to 4 times its concentration, something about camels, can double. Kangaroo rats can triple humans. Okay, so a lot of stuff that's way better than humans. Yeah, absolutely. Now, we don't have a whole lot of numbers in here, but we expect to jump in and grab some points with maybe similar animals or with maybe reference to reptiles. Exactly, Sarah, because they referenced it here at the end. Cool. Let's jump in and do some questions. First up, question number 1, or 7. First one from this passage. Kidney failure due to dehydration. Oh, awesome. Pull in. You gave him reference back to what Elizabeth put in chat a second ago for a hint. But pull in. While you're doing that, I want you to watch out for one thing. It wants to know what is due to. It could be very easy in a problem like this to accidentally match to a consequence. So remember, we don't want to go from kidney failure, dehydration to a consequence answer. We want to know what caused it. Hopefully that hint helped a little bit, because there's 2 answers that seem to be getting very few votes. First of all, which one did you eliminate right off the bat? Give me one. One that you got rid of. Probably D, early on, Esther. A bunch of your classmates agreeing. D. Increased body temperature. Increased body temperature sounds like we're talking about thermoregulation, not necessarily kidneys specifically. And remember, if it's due to something, does temperature change or body change generally cause immediate kidney failure? That should stand out as probably an unlikely link, and certainly not one we saw in the passage. Okay, so we can get rid of D. Now, B, thank you, Esther. I saw Jordan get rid of it as well, right, Elizabeth? If we're talking about due to, inability to produce sufficient urine is a subsequent consequence that we would expect to see, but not an original cause. It would be the effect. Yeah, Kelsey. So, okay, we're down to A, inadequate blood volume. That sounds like it could be related to kidneys. And then C, buildup of salts and distal convoluted tubules. That sounds like relationship to kidney. So both of these are very tempting answer choices, but we have to keep track of which one would be a causer of kidney failure. And they give us a second hint, actually, which does let us get rid of the other wrong answer, even if we were tempted by it. They say severe dehydration. So hold on. In severe dehydration, you spotted this more, Nikki. Absolutely. In severe dehydration, we don't have very much water, and we have very high plasma osmolarity. And they gave us some hints, but we actually talking about this today. Super high plasma osmolarity. So where are the salts then? I know I just told you, but where is the salt if we have super high plasma osmolarity? Yeah, it's in the name, plasma osmolarity. So it's super high plasma osmolarity in blood, in plasma. Is it in the distal tubule? No, we're not even processing it. We have kidney failure. Can't be C. Impossible for it to be C. It's got to be answer choice A. Inadequate blood volume for effective filtration can cause kidney failure. And again, that would cause kidney failure. And even if we were tempted by C, we wouldn't even have a buildup of salts in the distal convoluted tubules because we don't have enough blood volume to process it. So it actually would be decrease in sodium excretion. So it would be less salt in the distal tubule because we just don't have flow through there. Elizabeth, pressure in Bowman's capsule and low pressure in Bowman's capsule. Well, we have low blood volume in the first place, so there is low blood pressure if there's severe dehydration. So yes, in part, but it wouldn't necessarily be pressure due to Bowman's capsule. I just want to be clear about that. Pressure due to Bowman's capsule will be more like kidney stone, right? Because if we had a kidney stone blocking, then that blocking would cause a buildup of pressure in Bowman's capsule, which would route it back up into the capillaries instead. Yes, exactly, Jennifer. But lower pressure originally. Yeah, exactly. Exactly. Correct, Elizabeth. I just wanted to be clear because some people get those things confused. Bowman's capsule excess pressure would be due to something like a kidney stone, but Bowman's capsule, the difference, right? Talking Starling forces, that's kidney 1, but the difference between the actual pressure coming in and the pressure from Bowman's capsule, yes, that would be, the difference would be less. So our NFS would be a lot less. Cool. Okay, last couple questions. I think we've got 3 more left. This is a lovely one because it's basically just a quick reference to the passage. Let's take a look. Remember, where are we going in the passage? Last paragraph, paragraph 3, answer Dory, right. Okay, now we're scanning down through. There's a hint. We want to gain considerably more water than we would lose. All right. I don't even know if I have to go through this in any more detail because we've already got over 90% for the right answer, crushing it. Absolutely. Camels and kangaroo rats were both mentioned in the passage. We did have them having the ability to have a huge concentration of urine. So if we have the high plasma osmolarity, blah, 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 4 to 1, yeah, but they can concentrate up to 4 times more than humans. Perfect. So they should be able to have seawater input and actually retain some water from that. You know, considerably more water than they lose. I don't even, considerably isn't really a term that gives us a particular number. Some amount of more body water than they lose. Not necessarily going to be liters and liters, but yes, we would have retention. So camels and kangaroos are the only 2 that can do that. And certainly we could have gotten rid of humans because we know humans can drink salt water, which also gets rid of C. Maybe we would have been tempted by B, but the passage does give us both kangaroo rats and camels. Nicely done. Okay, next up. I will go ahead and clear off the poll. I'll let you try this one out on your own, but let us know down here in chat, what are the clues they've given you that helped you quickly solve it? Go for it. All right, I like some of the answers coming down through here. The one I like the best maybe is Esther's link here. Right, Philip, absolutely right, Estelle. So thinking, all right, we've got a 3 to 5 gram of salt, a 15 to 30 gram, blah, blah, blah. The clue, we had acclimatization of many weeks. This is long-term reaction mechanism. So we've got to scan through the answer choices for one of these that mentions something about long-term or something about hormone response, specifically steroid hormone response for long-term reaction. Exactly, Esther. So scanning through the answers, we don't know necessarily anything about sweat change. A is gone. D is vasopressin. That's a peptide hormone. Get rid of that one. And yes, absolutely, we have right there at that 90% cusp. I don't know. I saw it hit 90% a couple times on this one. So I think it's still black star of doom. Absolutely. Answer choice C. Aldosterone is a long-term response. That is a systemic response. That is a steroid hormone. Absolutely. Now, to Tristan's question, that's a great follow-up question. But the question stem describes a scenario where salt excretion drops considerably. Aldosterone does act on salt. So what hormone has a role to play in salt retention and secretion? Got to be aldosterone. Now, does aldosterone trigger sweat glands? That's not necessarily at play here for the vast majority of MCAT systems, but certainly aldosterone would impact the level of salt through sweat glands and kidneys, right? Not necessarily whether we'd have more sweat or whether we'd have more processing, but it would impact the amount of salt flow. So, yes. Right, indirectly. For sure indirectly, absolutely. But it would impact the amount of salt, which is what the question is asking about. Good follow-up, though. Last one of the day, this is our final we're going to close out with. We actually kind of gave you a little preview of this in class by accident. but I'll give you about 30 seconds to try it out. All right, I see a huge pull for the right answer. Already 3/4 for the right one. I like it. I like it. Let's jump in. We talked about this briefly when we were running through the figure that had a bunch of different points on it, the ADH point, the aldosterone point, the squiggly lines from the beginning and the end, a lot of the stuff that we referenced back actually from Kidney 1, and it's trying to confuse us. Kangaroo rats do something else, and we compare their nephron to our nephron. Well, they're concentrating urine better. So we'd love to see an answer that mentions something about collecting ducts or loops of Henle. All right, well, A, shorter wouldn't be any good. B, shorter wouldn't be any good. It's got to be C or D. Now, I mentioned this when we were running through it because this is something that you should know, but which one of them actually relates to being deeper in the medulla and transferring waste process? Okay, that's important. That's the loops. Exactly right, Leonie. Correct, Esther. The loop of Henle is that mechanism. It is that process. The collecting duct could give you 200 milliosmoles, could you 400 milliosmoles, etc. But again, nicely done. We crushed this one. That is one more gold star before we close out for the day. And of course, if there's anything else we can help out with, do not hesitate to let us know. Hit us up in the QA, and we will stick around for a few more minutes. Otherwise, see you in another channel session down the line. Take care. Excellent class.